Hello, friends. Here is a question worth sitting with. Every time a computer adds two numbers, renders a frame of video, or runs an artificial intelligence model, what is actually happening at the lowest level? It all traces back to tiny switching circuits called logic gates. These gates do not process words or images directly. They only ever ask one question. Is this signal on or off? 1 or 0? From billions of those yes or no decisions, everything else is built. In this video, we are going to trace that path from the math behind those decisions to the physical gates to the tables we use to reason about them. Let us start with the algebra that makes it all possible. Boolean algebra is a system built on exactly two values, 0, which we read as false, and 1, which we read as true. There is no in-between. George Boole formalized this idea in 1854, and it became the mathematical backbone of digital computing nearly a century later. From these two values, we get three fundamental operations. AND returns true only when both inputs are true. OR returns true when at least one input is true. NOT simply flips the value, turning a 0 into a 1 and a 1 into a 0. That is the entire foundation. 3 operations, 2 values. Simple as that sounds, every logical decision a computer makes is built from some combination of these three. Next, let us see how each of these operations becomes a real physical circuit. Boolean operations do not stay abstract for long. Each one is physically built as a logic gate, a tiny electronic circuit made from transistors that takes electrical signals as inputs and produces an output. The AND gate outputs high only when all inputs are high. The OR gate outputs high when any input is high. The NOT gate, sometimes called an inverter, flips a single input. From these three, we derive 3 more. NAND is AND with the output inverted, and it is actually one of the most universal gates in hardware. NOR is OR with its output inverted. XOR, or exclusive OR, outputs 1 only when the inputs differ. 1 0 and 1 1 gives you 1, but 2 identical inputs give you 0. These 6 gates are the building vocabulary of every digital circuit. Now let us use truth tables to map exactly what each one does. A truth table is a simple but powerful tool. It lists every possible combination of inputs and shows the output for each one. With 2 inputs, A and B, you always get exactly 4 rows, 0 0, 0 1, 1 0, and 1 1. That is 2 raised to the power of 2. Look at the AND gate table. Only the last row, where both A and B equal 1, produces an output of 1. Every other combination gives 0. Now look at XOR. The output is 1 only when the inputs are different. When A and B are both 0 or both 1, the output drops to 0. That difference between AND and XOR will matter enormously when we get to binary addition. Truth tables let us verify gate behavior completely without building anything. Coming up next, we will connect all 3 concepts into one clear picture. Let us pull this together. Boolean algebra gives us the rules. AND, OR, and NOT define what logical operations are possible and how they behave mathematically. Logic gates give us the physical form. Each gate is a circuit that implements exactly one of those algebraic rules using transistors and electrical signals. Truth tables give us the verification method. By exhaustively listing every input combination and its output, we confirm that a gate or chain of gates behaves exactly the way the algebra says it should. These 3 things are not separate topics. They are the same idea expressed 3 different ways, as math, as hardware, and as a reasoning tool. When you understand how they map onto each other, you can design circuits, read schematics, and debug logic errors with confidence. The last slide shows exactly where this foundation leads you next. Let us bring it all home. Boolean algebra is the 2-value math that defines logical operations using AND, OR, and NOT. Logic gates are the physical circuits that implement those operations in real hardware. Truth tables are the systematic tool we use to verify that any gate or combination of gates produces the right output for every possible input. Those three ideas work together as one unified system. And they do not stop here. Combine an AND gate and an XOR gate in just the right way, and you get a half adder, a circuit that adds 2 single bits. Chain enough of those together, and you are building the arithmetic logic unit inside a CPU. Every large system in computing grows from this foundation. Thanks for watching, and we will see you in the next one.